Next, I'd like to talk about the intersection point of a pair of lines. So this would be a set of two lines, sometimes called a system. So first thing I'm going to do is talk about systems of linear equations. We're going to talk about how to solve them. Then I'm going to talk a little bit about supply and demand curves. So when I have equations in the form y equals mx plus b, right, those are linear equations. And those solutions are is a set of ordered pairs. If I'm giving, its solution is a set of ordered pairs, its solution is a line, right? But if we're given two such equations, it's called a system of linear equations or a linear system. And its solution can be an ordered pair, which is an intersection, if they're parallel lines, I was doing so good, guys. If they're parallel, there are no solutions. Or if they're the same line, they are the same line, I would have infinitely many solutions. So let's take a quick look at that. So if I have two lines, they can intersect at a point, they can be parallel and have no solutions, or they could be the same line. That'd be more effective if I change colors, right? They could be the same line, and then their solution is every single point on that line makes this a true statement. Oh, I already say this stuff. Oh boy. So like I said, if the two lines intersect, they can have one solution, which should probably not be green. How about blue? One solution. If the two lines are parallel, they will never intersect, so they have no solutions. And if the two lines are the same line, the system has infinitely many solutions. So here's an example point of intersection for a graph. So I have the equation y equals 2x minus 9 halves and y equals negative 2/3 x plus 7/3. I graph both these lines and they intersect at this point right here. Lots of fancy fractions. To determine the two coordinates of the points of intersection, if I have two lines in slope-intercept form, I can set them equal to each other and solve for x. Okay, so this is the x coordinate of the point. After that, I need to substitute that value back into the equation and solve for y. Okay, and you can plug it into either equation. It doesn't matter. I'm switching back to orange. It doesn't matter. And that gives you your y coordinate of your point of intersection. So here I have 2x plus 3y equals 7 and 4x minus 2y equals 9. This is my system of equations. The first thing I need to do is get them both in slope-intercept form. I do that by solving for y. So I subtract 2x from both sides. That gives me 3y equals negative 2x plus 7. On the right here, I take 4x from both sides. Negative 2y equals negative 4x plus 9. Divide both sides by negative 2. Y equals 2x minus 9 halves. And I didn't even finish over here. Y equals negative 2/3 x plus 7/3. More fractions. So now what am I going to do is I'm going to set these two equations equal to each other. And I'm going to rewrite them up here so I can erase a little bit. We can have lots and lots of space because I think we're going to need it. Okay, here we go. So I'm going to set both of these equal to each other. I take negative 2/3 x plus 7/3 equals 2x minus 9 halves. Now, do we like working with fractions? In my land, no, I do not like working with fractions. So there's a way to get rid of these fractions. I could get rid of these fractions if I multiplied this side by 3, right? That would cancel out my denominators. But what I do to one side, I have to do the other side. So So let's do it. Get rid of fractions. 101. Next, I am going to multiply both sides by 3. That gives me negative 2x plus 7 when I'm all done. Here I have 6x minus 27 halves. Oh no, I still have a fraction. What can I do? I'm going to multiply both sides by 2, right? That'll cancel out this fraction. So that leaves me with negative 4x plus 14 equals 12x minus 27. Now you don't have to do this step, but I would, because it's easier to make less math mistakes this way. So now I just need to solve for x. So I'm going to subtract 14 from both sides. That gives me negative 4x equals 12x minus 41. Then I'm going to subtract 12x from both sides. I have negative 16x equals negative 41. And then I need to go ahead and divide both sides by negative 16. So I have x equals negative 41 divided by negative 16. That gives me x equals 41 over 16. Okay, so that's my x coordinate for my intersection is 41/16. I can now find my y coordinate, but I really don't want to. Okay, I will. Okay, so for our y coordinate, I take 4, or I could take either equation, right? Or I could plug it into the ones I'd solve for. But I'm going to take 4 times my x value minus 2y equals 9. Ooh. Okay, so 4 times 41, that's going to be 4 times 4. I'm going to get 164 over 16. I can simplify that. Thank goodness. 164 divided by 16. That 164 divided by 2. Let's do that. Divided by 4. So that gives me 41 over 4 minus 2y equals 9. So I'm going to go ahead and write 9 as a fraction over 4. Oof. So I have 41 over 4 minus 2y equals 36 over 4. And I'm going to subtract 41/4 from both sides. I told you we needed all the room we could get. That gives me negative 2y equals negative 5/4. Keep that in mind because we're moving over here. Okay, so I have negative 2y equals negative 5/4. I go ahead and divide both sides by negative 2. That means y equals negative 5, positive 5/8. And we're done. Oh, that was a lot of work. I showed you a really hard example. We're going to be doing a much, much easier examples on our homework. Okay? Because I know we don't have super high-tech calculators. If you have not gotten a scientific calculator, please let me know. We have 20 from last semester. If you have one from last semester, keep it, use it. But please shoot me an email if you do need a scientific calculator. Oh my gosh, it solved the answer for me. Okay, so here we have our graph. So let's solve the following system. Luckily for us, these are already set in slope-intercept form. So I've got 5x minus 1 equals 2/3 x plus 4, right? Because I have them both equal to y, those are equivalent, so I can set these equal to each other as well, in case I didn't clarify that. So I have 5x equals 2/3 x plus 5. I'm going to subtract 2/3 x. 5 would be 15/3. X minus 2/3 x equals 5. That means I have 13/3 x equals 5. I'm going to go ahead and multiply by the reciprocal here because that will equal 1. By the way, any number multiplied by its reciprocal, 1. That's always going to be the case. So I multiply 5 by 3/13. That means x equals 15/13, and that can't be simplified any further. But that's the x-intercept. Now I need to find the y-intercept. Sorry, not the y-intercept, the point in this system where these two equations intersect. I need to find its y-coordinate, because I found its x-coordinate. I need to find its y-coordinate. And I do that by plugging it back in. So I'm going to take y equals 5 times x, which is going to be 15/13 minus 1. So y equals 5 times 15, which is 75/13 minus 1. That'd be minus 13/13. 75 minus 13 equals 62. So I have y equals 62/13. This is just to show you that unless you work really hard, not all math turns out to really nice, beautiful numbers. Okay, let's find this to solve the system y equals -6 and y equals 2/3 x plus 4. So I'm going to set these equal to each other. I have -6 equals 2/3 x plus 4. Subtract 4 from both sides. I have -10 equals 2/3 x. Multiply both sides by 3/2. I have -30 divided by 2 equals x, so x equals -15. Now I could plug that back in and solve for y, but I already know my y is going to be -6, right? Because this is a horizontal line and a line with positive slope intersecting, and they intersect when x is -15 and y is -6. What about the line y equals 5x minus 1 and x equals -1? Well, I already know that x equals -1. So then I can just solve for y. Okay? Y equals 5 times -1. So I'm substituting it in. Minus 1. Y equals -5 minus 1. So y equals -6. So here's our point of intersection. For every quantity of a commodity, the supply curve specifies the price, okay, that must be charged for a manufacturer to be willing to produce so many amounts of units of the commodity. So if so this is kind of a supply curve. This is definitely a supply curve. The opposite of that's a demand curve. And that means that for every quantity, the demand curve gives the price that must be charged in order for Q units of a commodity to be sold. So let's suppose the supply and demand for a quantity, right, is given by these two equations. And I want to determine both the quantity and the commodity, okay, quantity and commodity, that will be produced and the price at which it will sell when supply equals demand. So I would set both of these equations equal to each other and solve. So we must have 5,000 units at $3 a piece.